In question 6, we want to find the exact value of each expression. For these problems, you want to start to make sure that each angle is represented in the standard position, that's between 0 to 2 pi. You will have a unit circle for the final exam, so the good news is you can kind of look up some of these values. But again, you should still know how to get them by hand, simply by having the information memorized for the 30, 60, 90 right triangle, as well as the 45, 45, 90 right triangle. That's the part that corresponds to that first quadrant of the unit circle. And then knowing how to do reference angles and attach the appropriate sign using the all students take calculus. For the first one, if you work this out, the sine of 5 pi over 6, that's going to be an angle in quadrant 2. So we then know the sign should be positive there. Its first quadrant reference angle would be positive pi over 6. And that's going to have a sine value of 1/2. Again, because it's in quadrant 2, the sign should be positive. So the final answer on this one is going to be positive 1/2. If we look at number B, this is the cosine of 7 pi over 4. 7 pi over 4 is not in the standard range, so you would want to go ahead and subtract. Oops, excuse me, I take that back. It is in the standard range. That is between 0 and 2 pi. This is going to be an angle. 7 pi over 4 is going to be in quadrant 4. Its first quadrant reference angle would be pi over 4. And we know that the cosine of pi over 4 is the square root of 2 over 2. And we know that from all students take calculus, cosine should be positive in quadrant 4. So the answer to this one is a positive square root of 2 over 2. The next one we look at is the tangent of 7 pi over 2. This one is not in the standard range. It's more than 2 pi. So we can find a coterminal angle by subtracting 2 pi, which is the same thing as 2 pi over 1. This would be 7 pi over 2 minus 4 pi over 2, which is going to give us 3 pi over 2. We know that trig functions of coterminal angles have the same values, so this is equal to the tangent of 3 pi over 2. This is one of our known quadrantal angles. 3 pi over 2 is right here. On the unit circle, this would be the ordered pair 0, -1. The tangent of that angle should be the ratio of the opposite over the adjacent, or it's the y over the x value, which is going to be undefined, because you get a -1 divided by 0. So the tangent of 7 pi over 2 is going to be undefined. The next one we come to is the secant of negative pi over 6. A convenient way to do this one is to first of all, there's a couple different ways you could do it. First thing that some people might want to do is convert negative pi over 6 into a coterminal angle that's between 0 to 2 pi by adding 2 pi. If you do this, you would get 11 pi over 6, and then you could work out the secant of 11 pi over 6. That's a perfectly good way to do it. A slightly faster way, maybe using our identities, is we know that the secant is a reciprocal of the cosine. This is 1 over the cosine of negative pi over 6. We also know that the cosine is an even function. So the cosine of negative pi over 6 is the same thing as the cosine of positive pi over 6, which we should know immediately is the square root of 2 over 2. So the answer is going to be 1 over the square root of 2 over 2, which is, keep, change, flip, 2 over radical 2, which when you rationalize should give us the answer square root of 2. The next one we come to is the cosecant of 14 pi over 3. 14 pi over 3 is not in the standard range, so you would want to begin by subtracting 2 pi to start. This is the same thing as 2 pi over 1, so this would be 14 pi over 3 minus 6 pi over 3, which would be equal to 8 pi over 3. That's still not in the standard range, so we want to subtract a 2 pi again. 2 pi is equivalent to 6 pi over 3, and this would now give us 2 pi over 3. So this is going to be equivalent to the cosecant of 2 pi over 3. To find the cosecant of 2 pi over 3, what we would probably end up doing is first of all finding the sine of 2 pi over 3 and then doing 1 over that, because cosecant is reciprocal sine. Now, to find the value for the sine of 2 pi over 3, we recognize that 2 pi over 3 is in quadrant 2. its first quadrant reference angle would be pi over 3, and we know that the sine of pi over 3 is the square root of 3 over 2. The sine is positive in quadrant 2, so the value for the sine of 2 pi over 3 will be a positive square root of 3 over 2. So our final answer is going to be 1 divided by the square root of 3 over 2, which is the same thing as 2 over the square root of 3. And if we rationalize that, we get 2 square roots of 3 over 3. So that's the value for the cosecant of 14 pi over 3. Lastly, we have the cotangent of the negative pi over 2. Again, first find an angle that's coterminal to negative pi over 2, that is between 0 and 2 pi. We can do this by adding 2 pi, which should give us 3 pi over 2. So this is going to be equal to the cotangent of, 2. The cotangent of 3 pi over 2. That's one of our known points on the unit circle. Again, it's that quadrantal angle that has points 0, negative 1. The tangent is usually the y over the x. Therefore, the cotangent should be the x over the y, which is going to be 0 over negative 1, which is the value 0.